Good day, everyone across North America. This is John Garmendi with Sony's Professional Solutions of America, welcoming you to another in our series of Tech Tuesday AV Solutions webinars. After a break for the Labor Day holiday, I hope everyone enjoyed their time off. We're back to it, and as everyone knows, these webinars were started in response to the COVID crisis so that our customers, resellers, integrators, and consultants can stay informed and up to date on Sony's latest products and solutions. Today's webinar is part of the application and technology focus series we started during the month of August. This week we'll be highlighting our UWP-D wireless system and the integration of Sony's PTZ network cameras. Before we start, a few items of housekeeping. As in previous webinars, there'll be an opportunity for Q&A, so please submit your questions via the GoToMeeting question panel. I'll post links to information referred to during the webinar in the chat panel, and I'll also post a link to our YouTube playlist where you can view all of our archived Tech Tuesday webinars. Joining me today will be our Pro Audio Product Manager, Andy Munitz, and returning will be Senior Product Manager for Network Cameras and Business Projectors, Drew Buttress. I'll turn it over to Drew first for his presentation, then he'll turn it over to Andy, and I'll meet everyone back here for Q&A.
Thank you, John. Appreciate the intro. We have in the past done webinars like this concerning our new X Series cameras, but today we're going to focus on audio and its application as it's related to the cameras. So the new X Series cameras, the BRC, X400, SRG-X 400, SRG-X 120, they're Sony's first 4K IP streaming cameras, and they have the NiMH capability. The big advantage for these is the applications. The BRC can fit into a lot of broad applications like small broadcast studios, be used in larger auditoriums and event halls, and certainly were applicable to the faith-based community. The two SRG models really are B2B models. These can go into corporate spaces like video conferencing rooms. We see these used a lot in local government, certainly small and mid-size, faith-based, and then in education, they're very popular. And with the recent events of COVID, we're seeing more and more people needing to be able to stream whatever that content is, whether it's streaming, for distance learning, whether it's a remote worship service. But the whole point is that being remote due to COVID increases the application of using a PTZ camera with audio to solve that streaming application. So with that, I'll get into some of the highlights of this new series. First is the X-More-R. With the X-More-R, that is what we call a back illuminated sensor. And what we've done is we've moved the photodiode layer out in front of the traditional metal wirings. And so as a result, you're able to capture much more light, and it really helps reduce noise when you're in a low light situation. Clear image zoom. This is a technology where it is not digital zoom as everybody thinks of digital zoom. When we go beyond the optical zoom range with clear image zoom turned on, we're actually bringing out pixels that were scaled out of the original image to create either the 4K or the full HD resolution video. And so what happens is we get to the end of the 20x. If we're running in a 4K format, you can go to 30 times. If you're running in an HD format, you can actually achieve 40 times clear image zoom. You don't get that pixelization, that big blockiness that you see with traditional digital zoom. So a very, very nice way to extend the actual optical zoom capability of the camera. With the BRC X400, we also have what's called 2x tele mode. And with that, we're now taking the center 1920 by 1080 cutout, the actual raw cutout from the imager. That increases your zoom range all the way to 80 times with clear image zoom turned on. The other advantage to these new cameras is we've increased the horizontal field of view from 65, our traditional horizontal field of view, to 70. So we're able to bring in more image data on the sides, especially in smaller spaces. And as I mentioned with NDI, that's the new tech interface for IP and audio transmission over a network. So with these cameras are PoE plus, and with that you're able to provide power, control, and bring your image data back all across a single Cat5e, Cat6 cable. If your customer is not looking to do NDI, that's okay. These cameras can do RTSP streaming. One of the big improvements on this camera is what we call, we've increased actually the speed of our preset recall from 100 degrees a second to 300 degrees per second. And that basically allows the camera to move very quickly from one preset position to the next. The result of that, though, is you would see a lot of image blur. So we introduced a new feature called picture freeze preset, and on a preset recall we actually freeze the image on that last preset position as the camera moves, and as soon as the camera's stable we turn the video back on live. PTZ motion sync. Traditionally cameras, our PTZ cameras have a two-step preset recall. We'll do the pan, tilt, and then the zoom. With PTZ motion sync, we're going to run all three motors at the same time. Obviously the goal is to start and end at the same moment in time. However, if you're not changing the zoom very much but you have a long pan, the zoom will finish first, because we can't drive the zoom motor that's slow enough to line up. It becomes unstable. But anyway, you get the intent here is that all three motors are going to stop, and we're going to try to start and then we'll try to stop at the same time. Just some specs. I wanted to show you the differences. The BRC-X400, again, 20x optical. It does have the clear image zoom, and it has the 2x teleconvert. The camera does have a tally lamp for those broadcast applications where you might have a multi-camera shoot and you want the talent looking at the right camera. And then as you can see, there's a BNC connector in the lower right corner. That is for your Genlock or external sync. The SRG-X 400 and X120 are full HD cameras out of the box, but there is an optional upgrade license to turn on the 4K feature if your customer wants a 4K path. You can see we've dropped the tally lamp and we've dropped the X-Sync. The SRG-X 400 is 20x optical and up to 40x with clear image zoom. The SRG-X 120 is 12x optical. There is no clear image zoom on the back end, but there is up to 12x digital zoom. So now we'll get into the audio portion. So looking at the back of the camera, you can see we have a mic in. They're actually, you'll see in an upcoming shot, these inputs can be set for microphone or for line in, so balanced or unbalanced. You can see it, they'll take stereo or just two separate mono channels left and right. Those are 3.5 millimeter mini jacks. What happens is you will log into the camera's web UI, and from there you would go to the settings tab, and then once you've got the settings tab on the left hand side, you'll see a menu item that says audio, and when you click on that, you will go into the audio setup screen, and it's from here where you can select whether your inputs are line or mic. You have the ability to actually turn on the audio level control, and with that you're able to adjust the mic volume up or down based on the levels you want it to be. You've also got an equalizer, and it's a very basic equalizer. It's either off, or if you turn it on, you have two choices. Low cut, which is for if the camera is in a situation where it's mounted, let's say on a ceiling, and above that ceiling there could be air conditioners. So we are cutting out the low frequency rumble, if you will. And the other is for voice enhancement, which is where we're going to boost those frequencies most common to the human voice. And then finally, you have the ability to turn on or off the audio in the IP for the RTSP or the NDI. And then the audio codec, you have your choice between 256 kilobits per second or 128 kilobits per second. And obviously the 256 is where you're going to prioritize in the audio quality, or if you're worried about how much bandwidth it's going to cost you, then you could obviously turn it down to 128 kilobits per second. And then finally, just so you know, the camera is doing the lip sync automatically, and we embed that lip synced audio into both the HDMI and SDI outputs. I mentioned that the IP is AAC encoded at 2 different bit rates. So what happens is we encode the audio, we timestamp the audio packet, we then embed that into the H.264 or H.265 encoded video packet, and then that video packet is also timestamped. And what happens is if you're using something like VLC Viewer or Wowza Streaming Cloud, their embedded viewer will take those 2 timestamps and they will perform the lip sync in software. And so with that, I'm going to turn it over to Andy Munitz to handle the audio portion. Andy?
Thanks very much, Drew. Thank you, everybody. Thanks for joining us today. And thank you, John. So before I jump into the slides, I just wanted to kind of maybe state the obvious and maybe some things to remind you about the importance of audio. We live in challenged times, and I think everybody is well aware that distance presentation, distance learning, all those kind of things have really become incredibly popular and very, very powerful. And I expect, as I'm sure many of you do, that this will continue for a mode for a while. It is really successful. The thing that I just wanted to stress, though, is that as incredibly powerful as video is for gaining our attention and to a degree, capturing and maintaining our, attention, audio is incredibly important, and it is not to be overlooked. Audio is one of those things, and if you realize it is the way that humans communicate through language. Yeah, you can show PowerPoint slides and things like that, but it is through language that we share ideas. And in order for those ideas to be transmitted with real weight, they must be clear, they must be present, they must be free from a lot of background room tone. They must sound like they're kind of up close and personal. And when we all watch, TV or we watch movies or whatever, not often realized or even thought about, but audio is captured with microphones that are very close to the presenters. And so they sound intimate. So in other words, that is as opposed to having a microphone that is either in your laptop or several feet away from a presenter, maybe on a shotgun microphone, but it will sound that it's that way. And if you basically will pay attention, movies and kind of TV shows are captured with sound done up really close. So anyway, that's one thing I wanted to make sure that everybody understood. Audio is very, very important to the message you're getting out there. So let's jump into the slides, and I'll tell you a little bit about our UWP-D wireless series. UWP-D stands for UHF wireless package, and these are just the pictures of some of the pieces in the product line. And we offer UWP-D not only in individual components where you can buy individual transmitters and receivers and things like that, but we offer them in very easy to use packages. The most popular one I would say is this one, the UWP-D21. This is basically a body pack transmitter with an included lavalier microphone, a portable receiver, and all the clips and the cables and mounting brackets, depending on the kinds of cameras you might want to map it to or attach it to. But if you look down on the lower right, you can see a couple of cables there. One of them is a mini to mini cable, and that will be very important when you consider how to connect the receiver into the back of our PTZ cameras. These UWP-D packages, the units themselves have little OLED screens, and they have a very wide operating bandwidth. If you realize that we use spectrum for wireless microphones, that is in the space that is normally occupied by UHF TV stations, but in every city, every TV station channel is not really occupied by a TV station. Where there are open TV stations, and there are in every market, then you can use that space for wireless microphones, for professional wireless microphones. And so we have a very wide operating bandwidth, which we refer to as 72 megahertz. Without getting massively into the weeds here, a TV station, when it broadcasts over the air, is 6 megahertz wide, and it carries all of the, the video and the audio and all that kind of stuff, and color, obviously. Well, inside of one TV station 6 megahertz system or spectrum, you can have a whole lot of wireless microphone channels because they're very small spectrum-wise by comparison. But we can cover the range with one of these units of 12 TV stations, and that gives you the ability to tune in 2,772 unique frequencies on these little units. Very, very great. And what that really means in a usability point of view is if you have a multi-room facility, for example, where you have a lot of classrooms or presentation rooms, and they're all maybe operating even at the same time, all with wireless microphones, you want to be able to be able to assign frequencies, unique frequencies, to each of the transmitters and receivers in each room so that they don't impact a wireless microphone system that may be in an adjacent room or downstairs or upstairs or whatever. So we offer that capability, and a professional system will do that. If you just maybe have a system that is operating on Wi-Fi or something, you don't usually have that capability, that flexibility, and you can also be impacted by all of the other Wi-Fi information that is usually flying around many, many applications. In addition to the UWP-D 21 system, we have a UWP-D 22, which basically has a handheld microphone instead of the body pack with lob. Same receiver, same cables, and pretty well clips, and same operating parameters. Also worth mentioning that there was something called an FCC spectrum auction that has happened over the last few years, where wireless microphones lost spectrum that was commonly used because there's so many cell phones in the market these days, and they needed more spectrum. So these can also be purchased, our systems can be purchased to operate in an area of spectrum which is called our 90 block, which is really up in the 941 to 960 megahertz range. It's arguably a licensed range, but it is kind of free from a lot of other interference that can be encountered sometimes. We have a UWP-D 26 package, and a UWP-D 26 package is like the 21 package in that it has a body pack and a lob and a portable receiver, but we also have a plug-on transmitter. And that plug-on transmitter, a lot of times you see in stand-up news environments, but it also can be used for putting a shotgun microphone on a long boom pole and holding it over talent. And that's sometimes the way that they make kind of movies and TV shows. So kind of talent will often have body packs and hidden lavaliers on them, but sometimes, depending on the camera shot, they can use boom microphone held over talent as well. In the UWP-D name, the D at the end stands for Digital Signal Processing, DSP. The reason that's important is because wireless, analog wireless in particular, usually uses a form of compression. Before you send the signal as a little baby FM radio station through the air to the receiver, your precious audio signal gets compressed. And then when it reaches the receiver, it gets re-expanded. And if you combine the word compression and expansion, you get compansion or companding scheme. And you have to have a certain methodology of the way that you compress and re-expand the signal. Well, that historically has been done with little circuitry, and circuitry is made up of components, and all components have various tolerances. So you never really get a perfect mirror image of the way you compress it and the way you expand it. In UWP-D, though, we decided to do that mathematically with mathematical algorithms, and that means you need to be in the digital domain. And then therefore you get a perfect re-expansion of the amount you compressed. If you look at these three waveforms, the sound on the left in yellow is the waveform of a sound source that's got a very sharp transient. You can see that sharp edge. If in traditional analog wireless systems, for example, that inaccuracy of that companding scheme tends to mush out that front edge, and it's that front edge in the letter T or K or sound effects or a ball hitting a bat or whatever it is that makes our human ears kind of say, oh, that sounds real to me. But if you mush it out, as in the blue graph in the middle, you lose some of that sense of presence and reality. Well, with our digital audio processing, our DSP, you end up with the graph that's in the green on the right, where we hold on to all of that sharp transient, and it's very, very, very accurate. Some other features of the UWP-D series is we have little OLED displays, which are really great, and the great Sony manufacturing and design. So these have a great fit and finish. They look and feel just like they are a real Sony product, but you're proud to own them because they are built very, very well, and they're professional, and they're meant to last. This slide talks about something that is the most important thing about wireless microphone technology. And you may have heard of the term diversity reception, but never really understood what it is. So if you take away anything from this presentation today, I want you to have a sense of what this is. What is diversity reception? It's a technology that can prevent dropouts in wireless microphone usage. But it's first important to understand what causes a dropout. So let's imagine that both of us, you and I, are in the same room and we're 10 feet apart from each other. And I'll take the role as the transmitter. I'm a little baby FM radio station, and you'll take the role as a tuning circuit. And in addition to your tuning circuit, you'll have one antenna that helps you pick up my signal better when you tune into my frequency. But as a baby FM radio station, if you think of me, I am sending my transmission waves in all 360 degrees. They're flying off of my antenna in all directions. And some of my waves, yes, will leave me and travel directly to you, as in the bottom graph, from the microphone directly to your one antenna. And you'll go, I hear you, what's the problem? The problem is that one of my other waves will or could reflect off of a hard surface. Waves that hit a hard surface reflect. They can be a hard wall, they can be a metal girder in the ceiling, they can be anything. But if that reflected wave now also bounces back and hits your same antenna, but by the time and the distance it reaches your antenna, it is exactly 180 degrees out of phase with respect to the wave that I'm sending you directly. In other words, the peak of its wave lines up perfectly with the trough of my direct wave. Guess what? What we learned in high school physics says that those two waves will cancel each other's energy out, and you get a dropout. And that multi-path interference, one path and the wave on the other path are two waves of multi-path. That's what causes interference. And it can happen literally when you're only 10 feet away from your transmitter and receiver together. So the question is, how do you protect against that? If I walked several hundred feet away from you as a transmitter and I started dropping out, that just means my radio station is not powerful enough to reach that distance. But I've tested our system out to many, many, many hundreds of feet. So to protect against the possibility of dropout, that is something called diversity reception, and there are three common ways of doing it. We use what we think is the most foolproof and the most reliable, which is called true double tuner diversity, which is to say that where before I had only given you one tuner with one antenna, I'm now going to give you a whole second tuner and its own antenna. So now you got two identical tuners and two identical antennas, and both of your tuners are tuned into my frequency as a transmitter. And between your two tuners, you're going to have a comparator circuit that is constantly looking at the relative strength of your two identical tuners, but one can always be stronger than the other one. And if a dropout condition due to that multipath interference even hints at happening, that one tuner's signal will drop in strength, and the comparator circuit, whose job it is to compare the two, will instantly transfer over to the good signal. And because of the wavelengths involved and the distance between the antennas, it is almost impossible to get a dropout on both antennas at the same time. So that is what is called true double tuner diversity reception. The thing to understand is another common way of doing it is to, if I took back one of your second tuner and left you with only one tuner, but still had you have two antennas, the switch happens between the antenna signal, not between the audio tuners, the tuner's audio signal, which can do a very fast crossfade, and it all happens automatically. But if you switch between the antenna signals, there is a possibility for an artifact to happen, depending on how the waves maybe line up. So the problem with the benefit of doing a single tuner but double antennas is there's less circuitry to drive, and it takes up less space inside of a package. But guess what we're great at Sony is keeping great battery life and making circuitry really, really small And so we do it, we think, is the best way. Another method is called adaptive diversity, where you have a single tuner, a single antenna, and an audio cable that may feed out into your camera. Is really an audio cable, but it's asked to act like a second antenna, but it's not really designed as an antenna. And then it does antenna switching between one kind of antenna and an audio cable. So that's also not as desirable. Now, a thing about wireless microphones, when you get into the professional world of professional wireless, is you have to choose a frequency. And you want to choose a frequency that is not occupied, it's quiet. And the idea is, well, how are you going to do that? Well, guess what? The tuners all listen to the outside world. That's their job. So you can instruct them to go out and scan the frequencies where you are and whenever you are, and pick you the quietest frequency, one that is not occupied by any other signal, and suggest it to you. But then you've got to take that frequency the receiver has just found, and you've got to tune the transmitter to the same paired frequency so that they talk to one another. Well, it used to be that you had to go into menus, and in many wireless systems, you have to go into menus. But we realized in UWP-D that there is a much easier way to do it using NFC pairing. NFC pairing is that little NFC logo that you see on the back of many of our cell phones these days. If you want to pair your cell phone up to a pair of Bluetooth headphones, for example, or a speaker, you just pair them up together by literally touching them. Well, guess what? We do that same capability now, or that same feature on our body pack transmitters and our receivers. In other words, you tell the receiver, without going into menus, hold down that NFC sync button for about 3 seconds. The unit will then take off and start scanning 188 different frequencies, and it will show you how much background noise on these vertical meters as it's scanning. And then after about 15 seconds, it will say, here is the quietest one I found. Would you like to send it over to the transmitter? And all you basically do is take the body pack and you face plant it face to face right on top of the receiver, so that the two NFC logos are basically right across from each other, and they share their information. The transmitter now vibrates in your hand because you can't see its display. It's facing the other receiver, and you now know that they are paired. They are on the same frequency. So it's a very simple process. Basically, hold the NFC sync button down, wait for the scan. The display will flash black, white at you, letting you know it's found the frequency. Pair the, face the two next to each other, and away you go. So a very easy way of pairing up. Now, in terms of what do, you obviously put the transmitter on the presenter, either a body pack or a handheld mic or what have you, and you clip maybe on the lavalier microphone, and you put the body pack in a belt, on your belt or something like that. The receiver then goes near the camera, and we supply those little mini to mini cables, and you can see here it leaves the receiver and it feeds into the back of the cameras, and there are audio input jacks that Drew talked about. As well, even though you would arguably change batteries on your transmitter, maybe on a day-to-day basis, they're good for many, many hours of operation. The receiver, though, can run on batteries, but it can also be powered off of a USB connection, such as a high-quality cell phone charger, and you can just leave it permanently powered on. It stays on its frequency. It never runs out of batteries because it's getting it off of AC, but it's feeding its audio directly into the back of the camera. But the obvious real benefit of having a wireless microphone on Talent is that the Talent is not hindered for movement. They can walk all over the place. They can just present like they used to. They want to walk up to a board or write notes or whatever. They can walk all around without the worry of having cables. So that's the benefit of wireless, if you have to state the obvious. Now, in addition to that, because we at Sony make both cameras, obviously, and we make audio gear, we have been able to design a very unique interface between many of our cameras and our wireless receivers, and it's called a multi-interface shoe, or MI shoe for short. What you do is you basically put this little shoe adapter on the bottom of the receiver, and you literally click it into a MI shoe camera that we have, which starts at our alpha cameras and goes all the way up to many of our professional cameras, but not in our shoulder cam, our big news kind of broadcasty big cameras. Those have different kinds of wireless slots. However, You just mount this receiver onto the camera through the MI shoe, and you're done. No cables are required. Audio goes right down through the shoe into this intelligent shoe, and you don't even need batteries in the receiver because you can tell the receiver to get its power through the camera's battery, which goes from the camera up through the shoe into the receiver. So that's really kind of very interesting. Another thing that is very nice to have and can literally save you some money in batteries over the course of the year is a real onboard battery timer in the transmitter, not just a little 3-segment bar graph, but also a count up hours and minutes battery timer. When you put in fresh batteries, you reset the counter to 0. And if you're used to getting 8 hours out of the set of AA batteries, and it only says that you've used it 2 hours and 23 minutes, guess what? You got a bunch more time before you have to put in new batteries. And that can really make a difference over the course of a year. Auto gain mode really means that you don't have to be an audio kind of engineer to know how to set this up. Just put on the microphone, talk into it, put on the lav, and the auto gain mode will adjust the audio level properly so everything sounds great. We also have a unique feature in the receiver, which is called channel memory function. Say, for example, you had a single channel receiver, which is what we've talked about so far, but you've got 2 transmitters on 2 talent, for example. Well, you know, on your TV's remote control at home, you've got a channel jump button or a last button, and you can hop back and forth between 2 channels. Well, we've incorporated that now in the receiver, where you just hit either the plus or minus button when you're on this channel memory menu, where you can stay at, and it'll literally switch frequencies between the 2 transmitters. So that's something we've added in this series. We also have the ability, say you have multiple cameras that all want to listen to the same transmitter. So all receivers need to be set on the frequency that matches the transmitter. Well, you can use that NFC pairing to very easily tell the transmitter to send its frequency over to multiple receivers. Literally take one receiver, hold it up to the transmitter, the NFC pairs them, pick up another receiver, hold it up to the same transmitter, the NFC pairs it, and away you go. And then all those receivers are ready to go. We also have headphone jacks, so you can listen, use these as personal monitoring devices, as well as their audio outputs. So that means you can listen to the quality of the signal as it leaves the transmitter and goes directly to the receiver and make sure that that signal is clean or is a personal monitoring kind of device. I won't go through this whole slide, but there is a very unique feature at the top, which is called occupancy sensor filter. As we have moved into a more green culture and there is new architecture out there that is green, you will many times find occupancy sensors in many rooms that will turn off the lights automatically when everybody leaves and save energy. It's a nice green thing to do. However, those occupancy sensors can operate either on little infrared wall switches, but also the other type is a ultra high frequency emitter that many times gets mounted in the ceiling and even has started showing up into wall switches as well. But it puts out a very high frequency, either 32 kilohertz or 40 kilohertz, way outside of our human hearing range. But we found out that that very high frequency can get into a lot of wireless microphones and cause the system to kind of misbehave a little bit. So we have used our onboard DSP to put in a filter that filters out those very high frequencies and prevents that problem from happening. Very unique kind of use of that DSP. So I won't go through the rest of this. Just to mention, we also have a dual channel portable receiver, which can take 2 independent wireless transmitters and bring them into their own channel inside the receiver. And the receiver has 2 outputs, so that you could put both of those outputs into a 2-channel input on some of our PTZ cameras that have both channels. It has all the other same capability, frequency, tunability, so on and so forth, spectrum range, and it even has a built-in mixing function, so you can take 2 channels and even map them to leave only 1 audio output. So even if your camera only has a single audio input, you can still use this receiver and have both channels be mapped to leave only 1 output of the dual receiver and feed the single input of the camera. So in review, the UWP-D series is digital audio processing for great sound quality. It has true double tuner diversity reception to prevent dropouts. It has great rugged construction, great fit and finish. It's got a very easy NFC channel setting mode. You don't even have to go into menus. It's got USB powering, so you don't need to use batteries in a lot of applications. But if you do use batteries, it's got a real hour and minute battery timer versus just a 3-segment display. It has an headphone output on the receiver, even with a monitoring mode. We can access up to 2,772 individual frequencies, great for multi-room presenters. And the transmitters will accept both mic or line level input on both the body pack and the plug-on transmitters. And the plug-on transmitters can even have something called phantom power, plus 48-volt phantom power for certain microphones that require that. To make sure that everybody knows how to operate this stuff, because people are used to using cameras, but it gets into the land of wireless microphones, they may get a little nervous. We have online training videos that will take you menu by menu and explain these features very easily. And you follow along with your own gear, and in the 10 minutes of the video, a little light bulb will go off in your head and you go, yeah, I get this. This stuff is easy. So don't feel abandoned that you have to, go to school to learn how to use this stuff. It's quite easy to use, but we make it so that you can learn quite easily. Finally, we are offering a promotion that unfortunately is over at the end of this month, September 30th, but we offer 2 promotions. We have a UWP-D and SRG bundle instant rebate currently, and that says that if you buy the SRG-X 400 or the SRG-X 120, and you buy any of our qualifying UWP-D models, UWP-D 21 or 22, or even our 2-channel URX P03D 2-channel receiver with a pair of transmitters of various flavors here, you will get an instant rebate amount, as you can see on the slide. As well, independent of that, but you can't combine it with it, we have a summer instant rebate on UWP-D alone, which offers just on the packages the amounts that you see below. So hopefully that kind of sums up and gives you a brief introduction to our UWP-D series. This gear is incredibly reliable, it's very affordable, it is very professional. And so thank you for tuning in. I guess, are there any questions that we have, John?
Hey, Andy, thanks. Drew, thank you. Yeah, of course, we've got some good questions as always. And let's see, we'll start here. Okay. Adele asks, can we use 2772 receiver in the same place? So can we use a 2772 receiver in the same place without interference?
That's a great question. So the idea is the tuning resolution of these units allows you to tune in 2,772 frequencies. But if you owned 2,772 systems, they could not all operate at the same time. There are limitations on how many channels you can have operating in one area at one time. But we use this stuff on, on reality TV shows and multi-actors, and we have wireless microphones have something called groups in them. And basically, if a whole bunch of systems are all tuned in and they use the same group number, that means that when they are asked to scan for frequencies, they will only scan frequencies that are known to be compatible, that won't step on each other. So that is the reason for groups. I have a training video in the link that I think John sent out and that I just showed that is a video just on the concept of channels and groups. But great question. In one scenario, you can have up to 16 systems operating in the same space in just one of the bands within 4 TV channels. But since we can tune into 12 TV channels in just one of these versions, and we offer this wireless gear in different block versions, a 14 block, a 25 block, and a 90 block. But within each one of those block versions, there are multiple bands. And within each band, you can, depending on your area, you can get up to 16 channels, be compatible with each other without fear of them interfering. Good question.
Thanks, Andy. We've got a follow-up question from Adele as well. What is the country of origin of the wireless mic system?
Where do we build it? That's another good question. We obviously are designing it in Japan. I believe that A lot of it is manufactured in South Korea, if I'm not mistaken, just so you understand.
Okay, so as in all of our other webinars, Adele, what we'll do is send you an email afterwards with confirmation for sure, just to make sure that that is the case.
But we have a lot of our products that are, made all over the world and certainly in Japan as well. So it's not always guaranteed for every product. Let me just tell you that way.
Thank you, Andy. So Andy, going back to the question of repack and the FCC Spectrum auction.
Yes.
I have a question here from Gene asking, are the Sony wireless systems compliant with the recent FCC repack and Spectrum auction?
Oh, great question and a big topic, but I'll distill it down. Really great question. Historically, back in the year 2010, the world of over-the-air broadcasting of television went to the DTV standard. We started broadcasting digitally, and that meant we could take those TV stations and compact them closer together without leaving guard bands between them. So channel 5 and channel 7 wouldn't touch each other, and channel 7 and channel 9, you had the space between. And those frequencies could then, after the compression, the compaction of them, we could sell off some of those frequencies to the cell phone companies, which were selling huge numbers of cell phones. Well, guess what? That trend kept going, and over the last 2 or 3 years, more frequencies were sold off to be used by cell phones. And as a result, some of those frequencies are no longer usable. And the FCC Spectrum repack that John is talking about said that we now have a different range, and all of our wireless microphones that we are selling today are FCC legal. And as well, we have given them this expanded tuning range, this spectrum tunable range, to help the user even more, that when they are in a particular location, if they have a much smaller tuning range, say it's not available, you can't find any frequencies, well, you better go get another wireless system. But if you have a system with a very wider tunable range, you will be able to get frequencies much more readily. So that's the idea. We are all compliant with the FCC Spectrum repack.
Thank you, Andy. We've got a couple of questions for Drew. Drew, we've got 2 questions from Brian. One asks about any built-in facial recognition capabilities on our network cameras, and the other asks why charge for 4K when it's already in there?
Well, both very good questions. The answer to the first one is no, the cameras do not have built-in facial recognition. We do have a AI-based edge analytics appliance, which will use facial detection when doing PTZ auto tracking, but it's certainly not facial recognition. The answer to the second question is a good one. Why would we charge extra for 4K? I think the answer is really, we have a lot of customers that are still in the HD world. They don't have budget or intention of moving to 4K. So then the question would be, why would they pay more for something they're not going to use? So by making the 2 SRG-X Series cameras 4K upgradable, it gives the option to those who know either today they're going into a 4K workflow, or if they think maybe 6 months from now, a year from now, we are going to switch to 4K, they can always come back to their account manager, their reseller, their integrator, purchase that optional license, and now they can turn on the 4K. If somebody wants the 4K right now out of the box, we offer that in the BRC X400, and that is priced higher than the SRG X400.
Excellent. Thanks, Drew. I've got another question for you from Terry. Terry asks, why are the audio and video packets both time-stamped?
Great question. And the answer is the 2 encoders actually operate at different speeds. And so I'm pretty sure it's the AAC encoder that's running faster, if you will. So what happens is when the audio packet is fully encoded, that gets timestamped and then put into the video packet, which is separately timestamped. And like I said, a lot of embedded viewers, I named two, VLC viewer as well as Wowza Streaming Cloud, their embedded viewer. They take those two timestamps and do the lip sync using software on the computer that's the viewer's running on.
Thanks, Drew. Question from Corey. This one's for Andy. I think you might have answered it during, but Corey asks, is this a one-channel wireless mic system? I guess he's referring to the UWP.
Well, we have the UWP-D packages, UWP-D 21, 22, and 26. Those are a single channel transmitter to a single channel receiver. So yes, it is one receiver.
And I actually see we're at time. So I know there was one other question. This was from Dean. Dean, I see your question asking about, would this equipment be suitable for recording spatially distributed music, such as a symphonic presentation? That's clearly a question for Andy. What we'll do is follow up with you by email. So, so from that, as I said, we're at time. Once again, I'd like to thank everyone for spending time with Sony as you do each week. We appreciate your time. We know it's valuable. If there are any other additional questions, or if you require an in-depth product demonstration, I would ask you to contact your local Sony reseller or your local Sony account manager. And looking forward to seeing everyone next week, when we'll give you a broad overview of our presentation systems, from our 4K Pro Bravia displays all the way on up to our CLED Direct View displays. With that, I want to thank you. I wish you all a great week. Stay safe, and we'll see you next Tuesday. Thanks, everyone.